Good evening. I'd like to welcome you all to the 32nd annual meeting of the Cognitive Neuroscience Society. I'm Michael Anderson from the University of Cambridge, and I am co-program chair this year together with Sabina Kastner from Princeton University. I'm the outgoing chair, and she is the incoming chair. I'd like to say a few words before we get started, words of thanks, because a conference of this magnitude, of this size, is no easy feat to put together. It's a very complex affair indeed. It involves no less than 6 different committees. For example, can't use my glasses. The program committee, the symposium committee, the poster committee, the Young Investigator Awards Committee, the Rising Star Committee, the CNS Trainee Association, not to mention the members of the Cognitive Neuroscience Society organization itself, like Kate Trethewey, Carrie Miller, and Lisa Munoz, for example. So all of these people have invested a significant amount of time in evaluating the content that's been submitted to our society to ensure that you have a high quality, cutting edge, exciting program to attend. Just to give you a little bit of a flavor, I got 2 microphones here. You get a little bit of a flavor of some of the content that you're going to be hearing about this year. Just in the invited sessions, we have a session organized by Anna Shapiro on the cognitive functions of replay, a session organized by Leslie Fellows on advances in lesion methods in cognitive neuroscience, a session organized by Ben He, which is kind of a deep dive into what EEG has taught us in cognitive neuroscience, and a session organized by Kai Huang of the University of Iowa on the cognitive thalamus, the attentional functions of the thalamus and the cognitive functions more broadly. And that's just the invited sessions. The members submitted sessions are more numerous and diverse and exciting than even that. I think you're going to have a hard time choosing which things to go to. I certainly, you're not going to be able to go to everything that you want to go to. I certainly won't be able to. This is not even mentioning the numerous and I think a record number of posters submitted to our society this year. The multiple sessions. I really encourage you to try to attend as many of these as you can, because it gives you a chance to talk directly face-to-face with the scientists producing some of the most exciting scientists on the horizon of our field. And I think they really appreciate it, and I think you'll really appreciate it as well. We have an array of lunchtime workshops which are easy to miss. As you're running for your sandwich outside because you're so hungry, you may overlook that there's a really cool workshop that you could be participating in that's directly relevant to you. So be sure to take a peek at that in the symposium, or in the program. We have, the Society has chosen to honor a number of distinguished scientists this year, both at the senior level and at the junior level. This year's George Miller Award recipient is Professor Ken Paller. The Distinguished Career Contributions Award is Professor Marie Banach. And then we have 2 young investigators, early career scientists, Emily Finn and Andre Bastos. Each of them will be giving an award address, and I think this is going to be really, really exciting to attend. You should check it out and see what all the excitement is about and why they were given their awards. On Sunday, when you're done checking out all the science you can handle on Sunday night, there's a performance by Pavlov's Dogs at the Cantab Lounge. You should definitely see. They're always a good time. The CNS Trainee Committee has organized a panel discussion on late Monday afternoon, early evening, and it's followed by a CNS trainee social immediately after that. And I think that this is talking about career possibilities for early career scientists. Immediately after tonight's keynote address, which Sabina will be introducing, there will be a reception in the lobby, and I look forward to seeing many of you there. Thank you very much.
Yeah, good afternoon. These are bright lights. Well, I'm Sabina Kastner. I serve together with Mike as a chair of the program committee. And I just want to say how incredibly happy I am to be in this community of strong scientists at this point in time. Now, it is my pleasure and a privilege to introduce our keynote speaker, Adriana Galván. Adriana is a professor of psychology and the dean and vice provost of undergraduate education at the University of California at Los Angeles. She's also the co-executive director of the UCLA Center for the Developing Adolescent. In her science career, Adriana has been focused on the adolescent brain development and how it supports developmental milestones during this important period of life. Her research expertise focuses on characterizing the neuromechanisms underlying adolescent behavior to inform policies that impact young people. Adriana has published over 130 scientific articles on the topic, and she is the author of a book, The Neuroscience of Adolescence. She received her BA in Neuroscience and Behavior from Barnard College at Columbia University and her Ph.D. in Neuroscience from Cornell. She has received multiple recognitions for her work, including from the National Academy of Sciences, the American Psychological Association, the Cognitive Neuroscience Society, and the William T. Grant Foundation. She is also the recipient of the UCLA Gold Shield Faculty Prize. In 2018, Adriana was a Fulbright Scholar in Barcelona, and in 2019, she received the White House Presidential Early Career Award for Science and Engineers, which is, I think, the highest honor for an early career researcher. So we are now looking forward to Dr. Galván's keynote address, and it's entitled Adolescent Brain Development, the Importance of Connections. Please help me welcome Adriana.
So nice to be here. I really enjoy this community, and it's wonderful to see friends and family. You feel like family from present time, and then also from all the years I spent training in various spaces. As Sabina mentioned, I'll be talking about some research we've been doing in our lab and labs across the world about how adolescence develops and how brain development during this time is essential for them to develop into adults. I really appreciate the opportunity to deliver this keynote speech, and hope you will find it informative. Imagine if there existed a group of people who laugh easily, prioritize bonding with others, could learn faster than anyone in this room, and embrace the uncertainty of life. We might call them superhumans. We'd certainly study them and love them and want to be them. Well, it turns out that this magical group of people live among us, and they're called teenagers. And that's what I'll be talking about today. Despite the bad rap that adolescents get in the very spaces that can help them the most, sometimes in school settings or in legal spaces, this talk I'm going to give is a feel-good story of adolescence and this wondrous time of life and what we can learn from them and how we as scientists can further advance their development by translating the science into spaces that need adolescents, policy and legal spaces. How do I know this? Well, besides the fact that I myself was a teenager at one point, I'm the second from the left there in high school. I am now the parent of an adolescent. That's my son Gustavo, who's 14. I've spent over 20 years studying the adolescent brain, and this is a picture from the 2003 John Merckx Fund Summer Institute at Princeton run by B.J. Casey. And some of the people you can see here have gone on to be some of the most renowned developmental scientists in the world. And at this time, upon reflection, we were just learning how to use cognitive neuroscience skills to inform the developing brain or understanding of the developing brain. And since then, we've learned a lot about it. In those early years, there was a lot of misconceptions about adolescence and often framed in negative light. When I refer to adolescence, I'm talking roughly the period of 10 or 11 or 12 when puberty strikes into the early 20s, when we adopt social roles that may be defined as adolescent-like or adult-like or more mature. There's vast variation during this time in life, but it does span a long time. And what's surprising is that despite the many years that we spend being adolescents, there's much less attention paid to it in terms of how many dollars we expend, federal dollars we expend, or how much attention is given to adolescence. This editorial in the journal Nature in 2018 characterized it as really nicely, and they said, a modern healthcare system without a focus on the unique challenges of pediatrics or geriatrics would be unthinkable, and yet there's no similar effort on behalf of adolescents. Luckily, that's changing because adolescents need us, and as I hope I will convey in this talk, we need adolescents. One testament to that is a relatively recent report, consensus report by the National Academy of Science and Engineering, The Promise of Adolescence. And throughout this report, I highly encourage you to read it. They note that the latest brain development research shows that the developmental period from adolescence through emerging adulthood features the creation of new neural pathways. And of course, that doesn't just happen ontogenetically, but it's in response to the environment. And so the environment that we create for young people is really important for how their brains will develop. And this narrative has helped shift how we talk about adolescence. In that same editorial from 2018, there was a note about how adolescence research must grow up. We need to stop giving adolescents a raw deal and start celebrating who they are. And in part, I think that this shift has happened because we've learned that our work can have an impact on the policies that impact young people. Policymakers and legal scholars turn to those who study adolescence to gain insights into how best to support young people. And I'll talk about that a little bit in the second part of the talk. What can we learn from adolescents? We can learn a lot. We can help them, but there's a lot that inherently happens during this transitional period of life that we as adults can learn from them. And I'll give a little synthesis of each of these areas of research that support these claims. The first is that we can embrace joy. Adolescents are really good at that, and sometimes we don't acknowledge it. The second is that adolescents are strategic risk takers, that all the risks that they take are important. They offer learning opportunities that the brain is primed to receive during this period of life. And finally, adolescents prioritize social connections. Perhaps now more than ever, social connections are paramount to who we are as a species, and we are inherently driven to connect with other people. And adolescents are really good at doing this, whether it's through online or offline. They embrace this opportunity to meet new people. When we are babies, we achieve developmental milestones during infancy. We learn how to walk and how to talk and how to bond with caregivers. And these milestones are best achieved when key developmental needs are met, primarily when we have support and love and attention that we need and deserve. And no one argues this point, that during this time in life, there's an optimal rearing environment that optimizes achieving these developmental milestones. What is less well recognized is that adolescents also have developmental needs. Obviously, they're not learning the basic things like learning how to walk or talk or bond with caregivers, but they're still developing. And so they too are learning through trial and error. During adolescence, we build on what was the foundation during early childhood. And we take these principles and the learning opportunities and the social connections that we make into adulthood. Along with a group of scientists who formed the National Scientific Council of Adolescents, folks who encompass different areas of expertise, we've identified these 7 developmental needs during adolescence. They include exploring the world and testing out new ideas and opportunities, building decision-making and emotion regulation skills. Because although there's dramatic growth in areas like the prefrontal cortex or emotion regulation systems, we need spaces in which to practice those skills. Adolescents are forming values, goals, and identity. It's no coincidence that adolescents are often at the forefront of new ideas or activism, and at UCLA we certainly saw this last spring, and a lot of other places did too. Adolescents find meaning and purpose through contribution. Contrary to the maybe popular narrative that adolescents are very inwardly focused, it's actually a time in life that when they seek out new opportunities to contribute to their community. and contribution has been associated with stronger mental health. Adolescents continue to need support from parents and other caring adults. We may assume that adolescents start to pay a little bit more attention to their friends and their peers, but actually they're paying just as much attention to those caregivers and adult supportive figures who have supported them throughout their lives. Adolescents are really good at identifying true and genuine respect among their peers and their adults, and often behaviors that we see as risky or ill-advised may be enacted because that is one way that they find respect among peers and adults. And finally, I won't have much opportunity today or time to talk about sleep, but that's an area of research I've been really interested in the past 10 years or so. And I know that Professor Paller will be talking about sleep in his address, so I won't talk about it here. And a few years ago, the keynote was Matt Walker, who talked a lot about sleep. But I cannot underscore how important sleep is for the development of all of these milestones and key cognitive needs that adolescents face during this time. Brain development is necessary for supporting these specific or adolescent-specific developmental needs. And when I speak to folks who don't study brain development, they often ask, well, what does it mean that brain development keeps happening during adolescence? Does it mean that the brain continues to grow in size? And that's not what we mean. What we mean is that there's refinement of the brain during this time. Sarah Jane Blakemore gave a terrific keynote a few years ago at this conference, and she described the particulars of what happens in brain development during adolescence. So I'll just briefly review it here. One is that brain development is organized and sequential. And what I mean by that, and as shown through this video, is that the different lobes of the brain, roughly speaking, develop from the back to the front. And that makes perfect sense. The brain is efficient across evolution. The things that happen in the back of the brain, you need right when you're born. The things that happen in the front of the brain, like cognition or future orientation or planning for the future, perhaps you don't need right away when you're born, because our parents do a really good job of scaffolding those cognitive skills for us. But during adolescence is when we continue to define those higher cognitive abilities. The second thing that happens is that there's refinement of brain connectivity. That means that brain regions are better able to communicate with each other. And that's emblematic of the connections that we're making outside of our brain, in our community, in our schools, with our families. And this refinement of brain connectivity has been the focus of a lot of research in adolescent neuroscience, because we recognize that this affords new cognitive skills, faster speed of processing, or the ability to have better connections between cognition and emotion. There's also significant brain plasticity, and certainly I don't need to share with this group the importance of brain plasticity and how our brains are reactive to the environment around us. That our brains unfold in particular ways, but that doesn't happen in a vacuum. That the environment and the experiences that we have a huge role in scaffolding that sensitivity to the changing environment. This is an image from a dendrite that was provided to me by Linda Wilbrecht at UC Berkeley, and she studies plasticity in the adolescent rodent brain, and so she can provide some insights that, of course, we can't get in human research. But what this video is intended to show is that there's very dynamic changes in the boutons that come off the spine, and that happens dynamically, obviously, and in response to new experiences. Here's a cartoon image that Dr. Wilbrecht has generated, showing that at any given moment, we are both gaining connections and losing connections. And that's one of the key hallmarks of adolescent brain development, that in response to the environment, we may be, in one moment, pruning away synapses that no longer serve us, because the job of the brain during this time is to refine and strengthen those connections that are relevant. In earlier life, that may be strengthening a language for a particular for the language of your parents. But in adolescence, that may mean honing a particular skill. We take in a lot of skills during adolescence: social skills, driving skills, abstract algebra skills. All of those things are new, and our brains need to be able to respond to it. So at the microscopic level, our brain cells are literally reaching out for new information. And that's why I personally find adolescence so fascinating, that there's no greater time in life, or it's maybe the last time in life when our brains are so dynamic and reaching out and seeking out that new information. When our spines receive new information, they form connections with other neurons. And this is specific to adolescence. Around puberty, our neurons can gain and lose about 25% of our connections each week, and this drops to about 10% by the time we reach adulthood. And I only illustrate this fact to show that there's a significant shift in brain plasticity later in life at the microscopic level. So back to this question of what we can learn from adolescence. I'll synthesize some research for each of these points. But before I do, I want to make the point that although we speak about adolescence in generalities, and certainly we need to do so when speaking to non-scientists, I recognize the vast variation in individual differences in young people. I often show this slide because I think it nicely illustrates how people who are the same age and the same grade as they are in this image can look so different, and in turn receive many different inputs from the environment. Does anyone want to guess how old these kids are? They're all the same age. 13, 12, 10. Okay, what grade are they in? 9th grade, 6th grade. No one has ever gotten this right. It's remarkable. Even people who study adolescence. All of these kids are 14-year-old 8th graders. And I really appreciate that because the boys on the far right could not look more different. The boy on the far right in the blue looks like he's in high school, and the one next to him looks like he's in, 6th. And so this just illustrates that when we do our imaging studies or when we talk to policymakers, we're treating everybody, all 14-year-olds the same, but obviously they are so different. And puberty, and this is where biology can really tell us, or why we need to keep in mind that adolescence is not devoid of the input of biology. So I say this, and please take all the research with a grain of salt when we group everybody together for the purposes of comparing adolescence to adults, for example. So what can we learn from adolescence? One thing I learned, and I keep in mind, and I probably study adolescence because I greatly enjoyed being an adolescent, was the importance of embracing joy. That when you have an overactive or hyperactive or sensitive reward system, your brain is paying attention to those rewards. In a second, I'll talk about why that's adaptive and important. This is a summary image of a lot of research we've done in our lab and labs around the world to examine the reward system in adolescence. When I was a graduate student at BJ Casey, there was actually really very little known about the adolescent brain, and that surprised us when we started to dig into the literature. We learned that there was a lot of understanding of what happens in earlier life or what happens in adults or even college students. But what makes adolescents so sensitive to reward? Or at least that was our anecdotal understanding of adolescence. And indeed, when we threw adolescents into the scanner, we nicely asked them to come into the scanner for us, and we put them in the scanner, and we showed them images of money or the opportunity to earn money. Or in a subsequent study, I gave them primary rewards, or we gave them social rewards. They all yield activation in dopamine-rich regions like the striatum. And this is a finding that's been consistently shown. And interestingly, even when given the same experience in the scanner, the adolescents show an exaggerated response. And so that told us a little bit about what the brain is paying attention to during the adolescent years. And later led to questions about, well, why would that make sense for us to have a time in life when we are more sensitive to the rewards in our environment? Mechanistically, we obviously cannot put in electrodes into the human adolescent to test the hypothesis that perhaps they have more dopamine sensitivity, because that was the obvious answer to that. And especially there were a lot of studies at that time showing that dopamine sensitivity led to greater reward sensitivity. But luckily, we have colleagues who do research in rodent models who can shed some light on that, and in non-human primate models. And the basic story is that if you compare dopamine release or the synaptic vesicles or the availability of dopamine receptors in rodent adults versus rodent adolescents, there's simply just more greater dopamine sensitivity in the adolescent brain. I found that fascinating because around the same time, there was a lot of research by Wolfram Schultz's group showing that dopamine did more than code rewards or recognize rewards. But in fact, dopamine was critical for learning about the environment. And that makes perfect sense if you have a group of individuals who are learning a whole new social landscape as they transition into adulthood. That research was done by Wolfram Schultz and his colleagues in non-human primates, whereby they would stick an electrode into their brain and were able to monitor how dopamine helped acquire new learning, or helped with the acquisition of how behavior right now would impact an outcome later. And those of you who were reading this literature at the time, in 2003, Fiorello and colleagues published this very seminal paper showing that dopamine was coding learning in the brain. That is, if you gave a monkey a cue with different varying levels of probability, that the dopamine would kind of stay engaged, the dopamine neurons would stay engaged until they learned about that outcome. This was really intriguing to me because at that point I really had a pretty simplified view of the reward system in the brain and thought it was really simply just coding for reward. I shared this at a talk, and Daphne Shohami, who's a colleague at Columbia, who didn't study adolescence, but she studied the learning systems in the brain and dopamine in adults, asked if I would want to partner with her and test the hypothesis that because the adolescent brain is more sensitive in these mesolimbic systems, perhaps not only did it make adolescents more sensitive to reward, but it also conferred benefits in learning behavior. And that's exactly what we found. I'm not going to go through the details of this study, but suffice it to say that we asked participants, adults and adolescents, to perform a very simple probabilistic learning task. And over time, what we found is that even though the adolescents and the adults showed similar learning accuracy early in the study, by the end of the experiment, the adolescents were outperforming the adults. And this was work done by Juliet Davidow when she did a mini sabbatical from graduate school at Columbia and came to UCLA and collected these data. Juliet also found that this greater outperformance of adolescents compared to adults in learning was accompanied by a greater prediction error-related activation in these learning systems, both in the hippocampus and in the striatum. And furthermore, that connectivity among these striatal and hippocampal systems, or regions in the brain, conferred greater memory positivity bias in the adolescents, whereby the stronger connectivity in the hippocampus and the striatum was associated with a greater memory bias in the adolescents if they had been positively rewarded. So here's where that reward sensitivity comes in, and it supports and amplifies the learning that adolescents do compared to adults. And again, coming back to the ecological validity of that, it makes perfect sense because as adolescents, we're faced with a lot of new situations, a lot of new social interactions, new skills that we're learning. And so it makes sense that we have a system that supports learning those new bits of information. This was supported also by research in Holland by Evelina Kroon, who's done a lot of this research also, showing that increased striatal sensitivity in adolescents benefits learning. And Dr. Kroon's work has shown this in all types of learning, cognitive learning, social learning, in ways that support this notion that it's not a coincidence that adolescence has this period in life when we have greater sensitivity in the very systems that help us identify rewards that we should orient towards and also support learning. And by the way, humans are not the only ones who show these changes during adolescence. Most species on Earth have an adolescent period of life when individuals take greater risks, when they're seeking out new social structures. And all animals do what adolescents, or humans do during adolescence. They spend more time socializing with their peers. They squabble with adults. They eat more food, and they fumble through a new social landscape. Because becoming an adult doesn't happen overnight. It requires learning, it requires mimicking, and whether you're a kitten or a puppy or a human adolescent, becoming an adult takes time, experience, and learning. And it's for this very reason that the adolescent brain is so special, because it's literally the bridge that helps kids enter into the next dimension of life. And when we do that, we're not always smooth when we're transitioning into adulthood, and we're often mimicking the social behaviors of adults. similar to the ways in which babies mimic the behaviors of those around them. I'm going to show you a video released when the book Wildhood was released a few years ago, and it kind of illustrates the social mimicry that needs to happen during adolescence, and I find it really charming. So look at these albatross. They're masters of this courtship dance. They're in sync. They're looking at each other. Okay. So they're using it to assess each other's suitability as partners. Okay. They're beautiful when they're doing it. Now you're going to see the teenagers doing it. They're not looking at each other. They're going in each different direction. They're doing it by the side of the road. And I love this so much because we do the same thing as humans, right? We see and hear, they learn these moves by watching the more mature adults. Our behaviors are mimicked by adolescents. I'm often asked about how bad is social media for young people? Maybe they shouldn't be doing it. Well, then maybe we shouldn't be doing it, because that's what young people are doing, is mimicking their parents. And this is the book is this wonderful book by Barbara Natterson Horowitz, if you're interested, about the journey that adolescents make into adulthood. The second thing we can learn from adolescents is how to prioritize social connections. They're really good at it, and sometimes we kind of get them in trouble for doing it, but the social connections that they are doing during this time are or the maturing connections in their brain are reflective of the ongoing connections they're making with their peers, with their families, and with their communities. We've recently done some research to examine the attributes or the benefits of pro-social behavior. What you're seeing here are data from a study in which we collected information from about 270 adolescents, ages 9 to 15, and a group of young adults. And they did a simple decision-making task where they were trying to earn money for either themselves or someone in their family, a friend, or a stranger. So, for example, they would choose whether or not to lose $1.50 in favor of their mom earning $3. These are very common pro-social tasks that are used to assess how people make decisions when it's going to benefit them versus benefit someone else. And what we found, unsurprisingly, is that costly giving, that is giving up money for yourself for someone else, varied as a function of age, and that it was differentiated based on who the target was, whether it was a family member, a friend, or a stranger. What a little bit surprised us is that the family person received the most costly giving behavior by the adolescent, regardless of age. And this actually increased as young people became adolescents and increased into the early adulthood age. There was significant activation in regions that, as Sarah Jane Blakemore described, are considered the social brain, that help us identify the feelings of others or take the perspective of other people. In this case, we found significant age-related differences in the dorsolateral prefrontal cortex when giving by age, where there was an increase during the late adolescent years that tapered off. So the systems that are ongoing maturation during adolescence are paying the most attention to who they are giving to and engaging these systems the most. And again, this is consistent with research on neural systems that became more engaged during their adolescent years. The last thing I'll say is about what we can learn from adolescents is how they make strategic risks. When we talk about adolescents, or the media speaks about risk-taking in adolescents, they're often thinking about this kind of risk-taking, maybe risk-taking that is ill-advised or may cause harm to the self or other. But when I think about risk-taking, during adolescence, I think about how adaptive it is for the adolescent, that if they're engaging in a risk, it may be adaptive for that person to gain social status, to form a social bond, or to leave the nest, so to speak. And so often adolescents, as I mentioned before, are trying out new things. Maybe they're speaking on behalf of a cause they believe in, or trying out for new sports, or engaging in volunteer experiences. As adults, we may not see this as risk-taking, but all of those are formative experiences that help shape who they are and are supported by enhancement of the mesolimbic system that is oriented towards risk-taking. We did a study a few years ago. It was a graduate student, Emily Barkley Levinson, who was interested in understanding whether or not adolescents are good at identifying advantageous versus disadvantageous risks. And so she used a task that had previously been published by Russ Poldrack called the Mixed Gambles task, in which adolescents are given a simple pie chart and asked, is this a risk you would be willing to take? And based on the expected value of each of those combinations of the offers they were given, some risks were advantageous to take, some were disadvantageous, and some were neutral. So it looked a little bit like this, not a little bit, this is exactly what it looked like. So they were either made, in this case in the upper left, this was a disadvantageous risk because you were gambling on winning $8 or $6 versus losing 18. An advantageous risk might offer gaining $17 versus losing 5, and a neutral risk had parity. And what we found behaviorally is that when we plotted out the expected value of each of these gambles and compared adolescents and adults who were receiving an fMRI scan, there was no difference in the choices they made when the risks were disadvantageous. So that told us a few things. One, the task was working. All the participants were able to identify the distinction among these different gambles they were offered. That, contrary to maybe popular belief, adolescents were not more willing to take disadvantageous risks. There was no difference in the neutral behavior, but differences emerged when participants were presented with an advantageous risk. And in this case, the adolescents were better able at endorsing taking an advantageous risk as compared to the adults. Obviously, these are very different types of risks than they face in the real world. But to us, it gave us some insight into how the brain is responding to risks that are presented to them, and also that adolescents were at least in this task, better able than adults to identify them. When they were taking these advantageous risks, the adolescents showed greater engagement of these same systems that I previously mentioned as engaging during social rewards or other types of monetary rewards. So we can learn a few things from adolescents. And I find this work, continue to find this work really interesting, but also have started to think how we can use the science to inform policies and programs that impact adolescents. Because if we let science sit on the shelf, then maybe it wasn't as impactful as we think it was. At the Center for the Developing Adolescent, which I run with my colleague Andrew Follini, we've learned a lot. We're not policy makers, we're not legal scholars, but we've learned that communication to these spaces are really important for us to translate what we think is the most important aspects of the science we do, which is on adolescence. And so we work hard to build this bidirectional communication among communicators, among policymakers, and of course among scientists. And this has led to some research, to some work that has impacted spaces that are not just in the laboratory. This is an amicus brief that a few of us signed on to a few years ago in Miller v. Alabama. And developmental science provides concrete evidence to support the argument that juveniles warrant different treatment in the justice system than do adults. Many other adolescent neuroscientists have been in communication with legal scholars about this, but it really is remarkable how much of an impact science can have when we are open to the communication with folks who have not been coming to conferences like we are, and understanding the benefits and the ramifications of the methods that we use. This kind of work in neuroscience and developmental psychology has led to several different Supreme Court rulings and rationales. A lot of them have been centered on the understanding that the brain continues to develop during adolescence, that it is plastic, that there's differences in peer influence during the adolescent period. And it has led to some significant changes in how we treat young people in the justice system. And I just highlight this as one example because obviously many different spaces, educational, system impacted, can have an impact, but the justice system is one that has stood out. colleagues of ours, B.J. Casey, Leah Somerville, Ariel Baskin-Robbins, nicely synthesized this research a few years ago. And the studies the Supreme Court rulings listed in this table are all for young people under the age of 18. But we know that the brain continues to mature beyond 18. And so in this review, they made the case that psychological and neuroscientific evidence for expanding the age of youthful offenders. They relied on terrific work by Ali Cohen, published in 2016. And this study was really important because it addressed an issue that is often asked of those of us who testify before different judges or in criminal cases, where they ask a simple question: when is an adolescent an adult? And we may take for granted, right? As scientists, we kind of have these age bins. In adolescent research, it's often based on the age of majority, which is age 18 in this country. But the study examined whether there are differences in cognitive ability or performance in emotional versus non-emotional contexts. This was funded by the MacArthur Foundation in some efforts that aim to merge neuroscience with policy initiatives. And what Ali and her colleagues found is that under non-threatening environments and very cold cognitive environments, there were distinctions in cognitive performance among adolescents ages 13 to 17, young adults ages 18 to 21, and individuals between the ages of 22 to 25, where there was a linear increase in their cognitive performance. However, they included a manipulation in the task whereby these individuals were making cognitive choices under emotional context or threat. And here you start to see a difference in the ways in which people make cognitive choices. And now the young adult group looked more similar to the adolescent group as compared to the 22 to 25-year-olds. This is really important research because sometimes I think we take for granted the distinct nuance in developmental maturation that, again, we as scientists may take for granted, but is very important in decisions related to policies related to young people. This research was really important for a recent, and it's nice that we're in Massachusetts, last year showing that the Massachusetts Supreme Court ruled against life without parole for emerging adults. The court's decision was influenced in part by a comprehensive review of scientific research on brain development. And this is the collective work of so many people who have taken their cognitive neuroscience research and amplified it and communicated it to folks outside of the lab. I testified in this court, and I have to say one of the most gratifying things I've ever experienced in my career was this text message. This is from the lawyer with whom I worked on this case, and he said, "We won, yay. No life without parole for 18, 19, 20-year-olds in Massachusetts. Over 200 people have you to thank for a chance of freedom. Ryan and I are going to the prison, blah, blah, blah," to tell our client. But it's just a reminder to me, sometimes we get stuck in our research labs and the details of an experiment or how we're going to submit a grant or write a paper, but people are paying attention. What we write in our discussion sections has a big impact in the ways in which those data are interpreted. So I mentioned earlier that at the Center for the Developing Adolescent, we aim to translate the science of adolescence into spaces that are not, for people who are not as versed in science. We do this a few ways. We've recently launched what's called Steps for Youth. It's an initiative that translates science to enhance policy success. We also provide briefs for folks who are interested in various topics about how, for example, anti-Black racism impacts development, social media impacts development, the importance of contribution during adolescence. And we also speak to various groups. We partner with TED-Ed to describe the science of adolescence. And I only display all this because when I was a graduate student, I never felt like it would be, I honestly thought it was important or I could have something to say, but realizing how important this is has been a really important part of the research I've been doing. In all of these spaces, we also remind folks that the impact of lived experience, the impact that lived experience has on adolescent brain development. We know that social structures and systems can support or challenge positive development, that communities and cultural practices support development. And finally, that early life adversity can have a significant impact on young people, even if it happens early in life, that ramifications can be observed in adolescence. But again, the beauty of adolescence is that the plasticity can help redirect those impacts of early life adversity. So I'll just end by giving or offering some thoughts about how we can support and continue to support the developing brain. And the first is that we can celebrate adolescence, that we can move away from a narrative that pathologizes a period of life that is so normative, that is not only unique to humans, and that is necessary for our transition to adulthood. We can invest in frameworks that recognize the whole person. We obviously do not develop in a vacuum, and so all of the spaces in which adolescents are reared matter for who they are. That we can provide adolescents with opportunities to contribute and to develop their identities, because often they may be changing during this time, but that is all part of the trial and error learning that happens during this period of life. We can support the inherent adolescent need to collaborate and to learn through social means. It's no coincidence that they like to spend time with their peers, offline and online. And that's because they are also learning the social rules that will help them transition into adulthood. And we can amplify their positive experiences and promote their health. There's a lot of discussion, rightfully so, about mental health during adolescence, particularly after the pandemic. But adolescents are not only their mental health. Andrew and I wrote a relatively recent article, calling for the need for young people to have experiences that boost their mental health, that rather than reacting to mental health challenges, perhaps we can support them before then, because we know that there are a lot of things we can put in place to support that. That is volunteering experiences, good sleep, as I mentioned, supportive environments or relationships with caregivers. All of those things support mental health before it becomes a challenge. And with that, I will end. Thank my lab members, current and former, my collaborators, my funding source, and also those who support our work at the Center for the Developing Adolescent. And thank you.